Welcome to Anything Maths. This is the second part of Surds. If you find this video helpful, please give it a thumb up. We're going to look at expansion and also rationalization of sets. But before we do that, I just want to remind you some key principles. It's in the previous video. The first one is root A all squared can also be written at root A times root A, and it's the same as root A squared, and this is the same as A. What can we learn from this? It means if you squared a root of a number, you get that number. It's so important. Example, root 5 squared will give us 5. The second key point is A times root x will give us A root x. As an example, two times root 3 will give us 2 root 3. They look quite simple, but they are really important when it comes to expansion and also rationalization of sets. Expansion. What we are going to do, we're going to look at a general idea of how we can expand sets. Then we look at many examples of different ones. And through those examples, you'll be able to understand how to do expansion in sets. So let's look at the general idea. Imagine you have A and we have B plus root of C. And you're supposed to expand this. The same principle, we have A multiplied by B, and we have A multiplied by root C. So it's going to be A times B plus A times root C. When you simplify, you get A, B plus A root C. Examples. Example 1, got 4, 6 plus root 2. Let's apply the same principle. This 4 multiply 6, and then 4 multiply root 2. We're going to have 4 times 6 plus 4 times root 2. And this will give us 24 plus 4 root 2. Second example, what about if we have root 2 outside, multiply by 3 minus root 3? It's the same principle. So root 2 will multiply everything in the bracket. We're going to have root 2 by 3 plus root 2 by negative root 3. And we're going to have 3 root 2 minus 2 root 2 times 2 root 3. And from the first video, we can put them together as 3 root 2 minus root 6. So that is why it is really important to watch the part 1 first before watching this video. The third example, 2 plus root 3 times 4 plus root 5. So it means these 2 will multiply this 4, these 2 will multiply this root 5, root 3 will multiply 4, and root 3 will multiply root 5. Let's see how it works. We're going to have 2 times 4 plus 2 times root 5 plus root 3 times root 4 plus root 3 times root 5. 2 times 4 is 8. We're going to get 2 root 5 plus 4 root 3 plus root 15. Okay. There's nothing we can do because they all are of different sets. So this is the expansion. This example is so important because it's going to help us with our rationalization. So pay close attention. 2 plus root 3 times 2 minus root 3. Now we have 2 brackets. They all have the same numbers in them, but there is some kind of a difference. The difference lies in the mathematical operation. One is positive, the other is negative. We're going to multiply 2 by 2, 2 by 3, this by that, and also let's do the work. If you multiply 2 by 2, you're going to get 2 squared. If you multiply, you're going to get 2 times negative root 3 plus root 3 times 2. Then we have plus root 3 times negative root 3. We get 2 squared minus 2 root 3 plus 2 root 3 minus root 3 all squared. When you look at the two middle numbers, they are the same but different signs, so they will cancel out. We're going to be left with 2 squared root 2 all squared. What does it tell you? It's just a difference of 2 squares, isn't it? So when you have a set of this format, just like example 4, is simply a difference of 2 squares. So you can simply start from this section and you can save you a lot of work and time in the examination. We can simply write 4 minus 3 and the answer is 1. Rationalize. How do you do that? We're going to look at a very general way to do it. Imagine you have 1 over the square root of x, and you are being told to rationalize it. Now, what you have to do, we want to get rid of the square root. Okay, if the square root is a denominator, I want to get rid of it. So how do we get rid of it? We use this trick. This same thing can be written as 1 over the root of x times 1, isn't it? But we can write a 1 as root x over root x, which means we're not going to change what we've been asked to do. Okay, so we have root x, but instead of 1, we multiply it by root x and divide by root x, because we want to get rid of the root x. When we multiply, we're going to get root x all over root x, all squared. And from our previous knowledge of videos, we know that this will be root x all over x. So it's quite clear that when you rationalize 1 over root x, what you get is root x over x. Let's look at an example. Some examples would help us. Example 1. 6 root 2. We want to rationalize it. All the examples are rationalizing. So it's going to be 6 root 2 times 1. We want to get rid of root 2, so we do the trick. Root 2, we multiply by root 2 and divide by root 2. Then what do you get? You get 6 root 2 over 2. And these 2 will cancel the 6 outside. We get 3 root 2. Great. So this is the answer. Second example, you are asked to rationalize root 3 over root 2. So we don't want root 2 down. We do the trick. Root 3 divided by root 2. But we want to multiply it by 1. But the 1 is the same as root 2 divided by root 2. If we multiply the numerator, we're going to get root 6. And if we multiply the denominator, we get 2. Nice and easy. We're going to look at a different format of rationalization. If you have 1 all over a plus root b, how do you rationalize it? We're going to use the same trick. We're going to be a plus root b. Just put them in the bracket. Multiply it by 1, but instead of multiply by 1, we will say a minus root b all over a minus root b. Okay, so if the sign between the two is a plus, when you are doing the trick, you do it a minus, and if it is minus, then it's going to be plus. So that really gives you an idea what is going to happen. Let's look at the classic examples. You have 1 over 1, 4 minus root 2 plus, let's make this one plus, Now we're going to have 1 all over 4 plus root 2. We multiply by 1, but we do that adjustment 4 minus root 2 all over 4 minus root 2. Okay, so that is a rule. You need to follow that. When this is plus, the trick will become 4 minus. When you expand the top, you're going to get 4 minus root 2. And the bottom is just the differences of 2 squared. What we did. That's why I want you to take these things seriously. And we're going to get 4 root 2 all over 16 minus 2. And you're going to get 4 root 2 all over 14. Another example, example 2. You have 2 into bracket 3 minus root 2. Remember, this is minus, so when you are doing the trick, it should be plus. So it's going to be 2, 3 minus 2, put the bracket around it, times 3 plus root 2 all over 3 plus root 2. Expand the numerator, we're going to get 6 plus 2 root 2. Difference 2 squares, 3 squared minus root 2 all squared. We get 6 plus root 2 all over 9, 2. We're going to have 6 plus root 2 all over 7. A third example, and final example, you have root 3 all over 1 plus root 2. You're supposed to rationalize this. We do our trick, root 3 all over 1 plus root 2. But remember, instead of multiply by 1, we change the sign. So it's going to 1 minus root 2 all over 1 minus root 2. Expand the top. If you expand, we're going to get root 3 minus root 6. This becomes difference of 2 squares. We get root 3 root 6 all over 1 minus 2, which is the same as root 3 minus root 6 divided by negative 1, and this becomes root 6 minus root 3. This brings an end to the second part of Surds. If you find this video very, very helpful, please give it a thumb up. And why not subscribe? Because soon I'm going to upload the solve examination questions on sets.